Hey, Pratik.
Hey Always, long time.
It's been a long time, right? It's been a long time. Really,
Indeed.
really happy to see you again.
My pleasure. Yeah, it all started in 2019, right?
Wow, it's been some time. I think back then I don't know, I was living in Europe back then. It feels like it's a long
Correct,
time ago. Yeah,
correct. At the time, everything was getting discussed was search and neural search, semantic search, all those topics,
yeah,
right?
yeah,
And we have come a long way. Then RAG came along, and now we're talking about much more interesting stuff.
yeah, yeah. I
Same.
mean, it's changed a lot, right? It's changed a lot. I mean, I think at that time I was working for Elastic, and I'm not
Correct.
sure what you were doing at that time. I think you were with some other company, right?
Yes, I was at a company called Task Human and then later joined Gina, where we
Oh
also did
yes,
the
yeah,
open neural search.
yeah,
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 basically, as I change companies, I've been giving talks with you, sharing what I'm learning on the way. So yeah,
yeah,
it has been fun. Thanks for organizing all the events.
yeah. I mean, it's been quite a, I think, quite a change, right, since the last couple of years. And I mean, I've been behind you to get you to do another presentation. You're really awesome at this stuff. And I was like telling everyone in my community, we need to get this guy. He's doing a lot of really interesting work in evaluation, and evaluation is such an important topic today. And
Indeed.
so, we're quite excited to have you here. I'm quite excited to see what you have to share for us today. So um, I'm
Yeah.
gonna I'm gonna give you the floor, and I think you have a presentation for us today, right?
Yes, I have presentation ready. Let me
Okay,
share. And
sure.
again, thanks for hosting me.
Yeah, you're welcome. Thanks for being here.
Sharing is not turned on. Let me send
Hold
the
on.
request. Yeah.
Yes, yes. Yes. So again, I just want to do a quick intro here. Pratik, if you want to add to anything, just let me know here.
Sure.
But yeah, Pratik is a good friend, and he's been in the space for quite some time. We have done some collaboration in the past, focusing on other topics like embeddings and so on, and search. We're both passionate about search. I think Pratik is still doing work on that. Once you do search, you never go back, right? But I think
Yeah.
the main focus right now is agents, and a lot of people really want to understand how to like put agents into production. I think for that to happen, in my experience, you need to understand like how to like systematically like improve the systems, right? And I think evaluation is such an important component of that. And so we're excited to see what you have to share for us today. If there's any questions, I'll let you know. I'll just ask you, as they come.
Cool, awesome, great intro. A bit about myself, just adding to Alvis. Essentially, I've been working on this different topics that have come along in last few years, which was initially search, a lot of few short work happening as LLMs came along. Then it went into the RAG, and then now we have like assimilation, all the patterns that we found to be working with LLMs, and now we are making like single agent, now multi-agent systems. So I have been touching base with a lot of these things in production, in experimentation, training models, different kind of use cases. And recently I've been working with Galileo for last 2 years, where my work is majorly revolving around evaluations and leaderboards. So I had like a lot of thoughts on this. I've been writing about this on the internet, but I felt like it requires a structure now because it has been so much information that it's easy to get confused and lost. So I feel like this is an attempt on a higher level to capture what I feel like how to go about evaluating agents. So it's like pattern of evaluating agent, not just like, okay, this is the library and this is the metric that you should be using. It's not about that. It's about how to think about evaluating agents. If I had gone in my old way, always, I would have called it like 101 ways to evaluate agents. Broke the pattern this time, but yeah, it's the similar kind of feel, I would say. Cool. So let's begin. So as you have seen, right, in real world, if you have built agents, you must have come along this kind of scenario where it's a very simple agent, let's say a banking agent. And then the user asks, like, do you have credit cards with good interest rate? And the agent says, give me your info, I'll get you started. So user provides the info about what type of credit cards he is interested in. And then agent takes a U-turn and says, okay, great, I have started your home loan app. Because internal semantically, it confuses loans as credits as well, right? And so it like completely fumbles up this kind of scenarios. And so the user is completely taken by surprise. And this is like how agents fail in real world. And we have been running this kind of experiments, which share more later in the slide deck. And this kind of failures actually happen because they are not deterministic and they confuse the semantics often. So the question then becomes, do you trust generative AI? And we all know that it's not going to work 100% of the time. There are stories around very large companies deploying agents to replace the customer support only to bring back the customer support, right? And because of that, it has caused a lot of chaos in the industry, and there is a need to make them more robust, and there are certain ways to make them more robust. It's not going to be still 100% perfect, but I think we'll be able to push it to the line such that users are not going to be having a simple fail scenarios, as I would call it. So as what we observed by talking with many people is that there are challenges across the phases of deploying agents, and there are like different kind of challenges. In development stage, which we'll call it, let's say, an experimentation stage, uh, the developers would be not so sure how to go about setting up their own LLM judge or how to set up annotation guideline. And so A/B testing of these different prompts and configurations becomes quite a chaos. And then what ultimately happens at many scenario places is that you have like your own 5, 10 samples for evaluation for certain use cases, and you do vibe evaluation over there, because of which you would be in the blind about all the use cases that will fail in the production. And when you put it into production in the second phase, if you're not integrated proper observability or evaluation callbacks into your system, you would be totally unaware like what is happening with different agents. And only way to know the failures is when your user complains about the product. But by the time it's too late and some damage has happened, and if you have like thousands of users, by the time you roll back, already a lot of damage is done. And God forbid, if you get into some legal case, you will be in the news and you'll be famous all over the world within a day. Uh, if luckily it still works for, let's say, 1,000 users and you want to deploy it to million users, the issues that start happening are you would not know how to do evaluation at scale, even if you had simple LMS judge or certain kind of heuristics to catch the issues that are happening with these agents. So that becomes a different kind of problem statement, which requires a different kind of engineering to solve around. So we discuss all these simple patterns that we have found out over the time. So overall, the story at the present moment is that as people put their apps from POC to production, the usage keeps on growing and the confidence keeps on falling, which is basically a dangerous scenario to have because you have rolled out a product and you can't easily roll back now. And it's so much happening that Gartner kind of did a survey of 1,000+ companies, and they found that 50% of the organization will abandon plans to reduce customer service workforce due to AI. So now they are thinking of more of hybrid scenario rather than completely relying on AI. The dream has been shattered essentially, and so now they need to be more pragmatic, and slowly now the approach is going to be gradual progress towards complete automation. So this is how I view evaluation timeline for an organization. It always starts with vibe checks, as I was saying, but then quickly they progress towards some systematic evaluation process, which can be human based or can be then AI assisted, which I would call level 3. And a lot of people are at this level. But then you need to set up processes which uses AI assisted evaluation as well as human assisted feedback, so that you can have as less human annotation as possible and still have a pulse of how the system is in production. So that is level 4. And then ultimately, as you roll out the product to millions of users, you need to be able to have your own metrics, which are fine tuned for your use case, which work at your scale. And then you will be much more confident that, okay, I am actually monitoring most of my outputs, and I know that this kind of failures are happening. We are creating insights out of it and fixing them on a regular basis. So that is what we need to kind of move towards. So today we'll cover a few topics. It's like essentially some obstacles in agent reliability. Then we have a playbook of how to move towards a reliable agent behavior. And then I will showcase a agent leaderboard, which we have been working for 6 months now, and what are the results out of it, and what kind of insights we can take away from it. So taking a step back, okay, I know all of you know agents pretty well, but just taking a step back and just defining the agents to get started from zero level is that they are basically a system that can plan, can take actions using the tools that are available, and they can have an orchestration that helps them accomplish the task. Cool. The components of the agents are usually some instructions around reasoning. There are a lot of ways to reason, right? As you know, chain of thought is not the only one. You can have like essentially tree of thoughts. You can have essentially chain of verification. A lot of different patterns have emerged, which help you push the performance. And you must be observing these patterns as you use today's tool like searching in ChatGPT or Grok or Perplexity. These patterns are utilized. Then we have the memory, essentially super essential for like the short-term memory as well as long-term memory, which is external. And then we have different kind of tools which can be just internal tools, or it can also be systems which interact external like web search. Now, what has happened essentially in which happened very quickly, I would say, from IT perspective, is that last year we were just talking about RAG, and quickly we have ramped up and we have moved towards a multi-agent system where the complexity has blown up so much that it's difficult to capture the context that is going to LLMs, and then what's coming out and where failures are happening and why they are happening. And because of that, debugging has become super slow, and we do not have clarity what to focus on, because there are like big issues which need to be fixed because they're happening majority of the time, and there are like small issues, the long tail, basically essential long tail of issues, and we require some way to prioritize these issues and fix them as soon as possible. So as we can define, the obstacles to reliable agents are unpredictable interactions. Why is this is important? It's obvious, but it's important because if we knew all the type of interactions that are going to happen, then we would essentially engineer the prompt and the system around it. And so we'll test it beforehand and then kind of make the system perfect. But the user requests are unpredictable, as well as the LLM's behavior is also unpredictable, leading to a completely unpredictable system to some extent. Then we all must have experienced it. We at the end of the day, all we have is either we define the architecture or we define the prompts, and we know that even a simple word or a simple sentence can make a lot of difference, and sometimes it's very explainable, sometimes it is not, and that creates a lot of problem for us. Maybe adding one instruction leads to removal of basically disabling of other instruction, right? Because we don't know how internally it kind of understands multiple requests that we're asking in the prompt. Then the context engineering issues, we are talking it again and again over the internet. Some people say RAG is dead, so just put all the context there. And some say, no, we need to have a really clean summary of context going into the models. So context engineering is still very debatable problem statement right now. And at the end, even if you have all this, you would not know whether your system is working correctly, because we do not have perfect evaluators. If we had perfect evaluators, we'll essentially reach the AGI, right? Because we can essentially get perfect data, and we can also train a perfect model because we know the perfect labels. So we don't have that, and it will take a lot of time or maybe never to get that. So all this essentially compounds and makes the whole thing blow up pretty bad. So question is, how can we make them reliable, right? And we'll go through a step-by-step process. that we have figured out. And if that is followed rigorously, it will take time. It's not a shortcut, but hopefully we'll get there. What we need to do essentially is to come up with process that leads to continual improvement of our system, because from day zero, maybe we launch the system that is kind of accurate in some cells 70% of the time. But as we see issues, we should be able to catch them. We should be able to create test sets out of it. We should be able to change the prompts. We should be able to run again some A/B experimentation, launch the system, and then again monitor it. So once we have that system in place, slowly and gradually we'll have a system that is acceptable in nature. So let's go to the reliability playbook that will get us to the end of the road. So first and foremost, I feel this is the most important part, is to get very domain specific, custom or non-custom, high and low level metrics. What does it mean? So when the agent, now metrics are of a lot of types, right? They're like the regular metrics, the correctness and hallucination kind of metrics. But we are talking today, we are focusing only on agent specific metrics. So I'll not talk about the other ones, the general ones. There can be a lot of PII and toxicity and other stuff. But I'm just talking about like measuring how the agent performance works. Have just 10 minutes. Okay, I'll go fast, a bit fast now probably. So first is to have the low level metrics. Why they're important? Because then you can essentially go and pinpoint the issue that, okay, this is where the tool parameter was passed incorrectly. This is where the tool selection was incorrect. Now, how do we know where this kind of issues are also happening, right? Either you have that metric or you also have a high level metric called something like task completion. So it's like they have thousands of samples and you want to focus on those samples first where task completion did not happen, right? The agent did not complete the task, which I would call the high level metric, where all the full context is passed to the metric, and the metric figures out, okay, there were these 3 requests by the user and the agent did not complete all of the requests. Maybe it forgot to complete, or maybe it just did it incorrectly. And so that's how we come to know that, okay, from these 100 samples, we have these 20 samples where this task was incomplete. In those, we then have the low level metrics, which would tell us whether the tool errored out from system perspective, or the tool selection and the argument parts were incorrect. So that those I call like the low level metrics. Now it is very possible that you want more metrics apart from this, to monitor basically certain things. So those will be like, let's say you want the agent to talk in certain tone, right? You don't want it to be too casual, maybe. So you have a tone adherence. Then you have, let's say, handover accuracy, that you want to monitor that, okay, I built this orchestrator agent system and I want to monitor just like how well it hands over the task. Or it can be just brand guideline, right? Like a lot of companies have certain kind of separate guidelines on how to behave, maybe related to policy, which can be internal policies on, like, let's say, refunds and stuff. So that those are like extra guidelines, so they need to be adherent to those guidelines as well. So you want like separate kind of metrics just to figure out, okay, is the error happening because of the tone? Was the tone not followed, or was the handover done incorrectly, or was the agent refunding things it was not supposed to refund? It was just supposed to say we can't do anything in this scenario. So you want to kind of find out those kind of issues as well. So the question then becomes essentially, which is, I would say, a hard question, is that how to build a great LLM as a judge? Because once you have that, a lot of things will start working automatically and consist of certain components, which are, to begin with, of course, there is LLM, but it's not so trivial. What we are observing is that it's not necessary that the LLM that is good at tool calling is also good at also evaluation. So you need to run some experiments for your own domain to figure out what LLM works for you. It is also possible the LLM is great, but it's so costly you can't use it in production. It's also can be question between should we use private versus open source. So you have to do the LLM selection very rigorously, because if you screw up that, you have screwed up a lot of things. Then there will be certain kind of reasoning instructions to break the inputs and outputs that you saw gave to the judge, to actually understand whether there was a failure or not. You can also give some positive and negative reinforcement with examples so that it knows what's correct and what's incorrect. It's basically few shot. Then you have to give the criteria for the output. Okay, this is 0 and this is 10, or this is 0 and this is 1. You need to definitely give the response schema. We all know that JSON is still a problem sometimes. A number of evaluation per sample that gives you like the self consistency, because LLMs are not perfect, but what we know from research is that if you give them many chances and then you average out the outputs, or that, okay, basically majority voting, then you can get a better evaluation. And then if you have a binary kind of evaluator, then you also need to set the threshold. So you need to focus on these small things, and maybe it's not perfect in the beginning and you see issues with the LLM as a judge, that it can't catch certain error. You see where it failed and you add those instructions again, and then over the time the judge improves.
I have a question for you, Pratik, before you go forward.
Sure.
Um,
Sure.
by the way, I think we have you for 45 minutes today. Will you have
Yep.
the time, the 45 minutes? Yes?
Yes, I have time.
Okay, cool. Yeah, because I mean it's really interesting, all the presentations so far. So there's one question on metrics, because you were just talking about metrics. So a
Yep.
question from the chat was, how do you decide, which evaluation metric is the most meaningful, let's say, given some agent framework? I think this is an interesting question, because like I think people that are getting started with evaluation, right? Maybe they have some agent, we have a lot of tools today that allow you to build agents really quickly, right? So the
Yes.
question becomes, what should I be evaluating, right? I think what you say here with the tool error rate, that stuff is quite complicated to build. I think for someone that's maybe at the beginning phase. But can you talk more about what process, how do you need to think about this stuff to select the right metrics?
Sure. So at the end of the day, we build agents because they're calling the tools, right? And so a lot of uh, success revolves around how it utilizes the tools, right? And there are a lot of things happening in the agent. They have a planning step, right? And they have a selection step, and then they can also have a basically self-evaluation step. So
Right.
if you have a simple architecture, essentially every span can be evaluated in some or the other way,
Right.
right? Because every span is a step. And it's up to you how much you want to begin with. But at the basic level, you need two things for sure. One is whether it's selecting the right tool and it's the right arguments to it. That's the first thing. It
Right.
can be two different metrics or it can be just one metric, up to you. And tool selection is a very big topic. I would say it looks
Yeah.
simple because it can be just single tool call. It can be the same tool call multiple times because it's like research on multiple topics and it calls all the tool parallelly. It can be different tools called. So it has a multiple combination of this stuff. And there's
Yeah.
also similar combinations with default arguments and not so default arguments in the functions also. So first and foremost, tool selection is super important, because if that's not happening, the task is definitely not going to get completed. And
Yeah.
secondly, whether after calling all the tools, whether the task was complete or not. There are two scenarios, as I was saying. One is that it forgot to complete the task, in which case the user can remind the agent that, okay, I asked for this, you have forgotten, and maybe it does it. But if user forgets, or if it's a very workflow kind of agent and it forgets to complete updating some database, it's not good. So, and maybe it income updates some database with very incorrect value, so that those kind of errors happen. So in that case scenarios, we say the task is incomplete.
Yeah.
Some people would define it as that failed trajectory also. So
Yeah.
it's not in the name, but you get the vibe that, okay, there is a low level errors and there
Yeah.
is like a complete overview of the thing where it has failed.
Yeah.
Two things to
So
begin with.
yeah, so the way I understand it is like the tool selection and the error rate is not something you ignore. It's low level, yes, but it will determine it's basically signaling how reliable that system is, right? How good it's calling the different tools that it has access to. Maybe you have a different way on how those tools should be called, right? And that has to do with the reliability of the system. I think
Correct.
what's more challenging though is like the task completion, right? So let's say like you had some
Yes.
kind of like question answering system for like a tutoring system, personalized tutoring system as an example.
Yeah.
How do you, this high level stuff, how do you determine like is there like a process or like framework people should be thinking, should they be experimenting with their agents, looking at the outputs, and deciding then, okay, maybe this matters a lot for how the agent is completing the task. Maybe it's about the, how safe the output is, maybe how efficient it is as well, because some people, they care about the cost savings, right? So there's different, I think, aspects of how you want to like, evaluate that final completion, right, of the agent. So I think that's kind of
Indeed.
what the, yeah.
Indeed, if anybody wants to build task completion, it will be definitely a few weeks of work,
Yeah,
where essentially they need to kind of have already an existing chat
right,
with an agent data coming from their existing system, or they need to simulate a system and get the data and then
yeah,
get it annotated by some annotator, right? Which
right,
knows what is to be done in those scenarios, or you can. Otherwise, it becomes recursive. Yeah, you don't have the LLM to kind of create the ground truth. So you need annotators to begin with.
yeah,
Um, and then give the different spans. Then what you have to do is, because you have the ground truth label, you have to convert the span, the whole trace and the span data into certain format and give it to the LLMs, and then see whether it also outputs whether it's incorrect and correct. Also, you have to do all the balancing of the data. You want the metric to be kind of working on a data that is having balanced ground truth, or do other kind of normalization to actually get the correlations done well. And then you will see definitely that at certain points it is having false positive or false negative, and then you keep iterating on the prompt so that you get the desired behavior. Still, it won't be perfect because it's difficult to get that unless you use like a very costly evaluator and have like multiple steps of reasoning. You can't do simple
right,
CO. You have to do multiple self-evaluation and stuff to get to
yeah.
a really perfect evaluator.
All right, thank you for adding to that. I mean, I think you can continue probably with the presentation.
Sure. Elvis, how much more time do we have from this point?
Yeah, I think we have 15 minutes, and how much more you can give us. So it's up to you, I guess, after the 15-minute mark. Yeah.
Oh, perfect. Okay, then I can go on bit because otherwise I'll have to hurry a bit. Cool. Then, so second point is about your experimental platform or infrastructure or your system. I mean, now gone are the times where we could just run something in a Jupyter notebook, dump into a CSV, and then just export it to Google Sheet and then do the annotation. I think that time is gone, and we can't do definitely with agents. So for this, you definitely need to pick a system. There are like open source solutions, and there are also like paid SaaS software available. You can choose what you feel comfortable with, but you need to pick something where, because of which you'll be able to get a detailed observability insights in a structured way, which will make you super easy to like go through different spans, traces, have metrics shown up on different places, have explanations, click on things, come out, aggregate numbers. This is not possible so easily because it's a nested data at times, right? And you can't do this in Google Sheets or any other way. So you definitely need a system for this. So choose anything you like, evaluate all the tools. But if you don't have this, then it's a lot of trouble to get it done. Then you have to break, essentially you run agents, and then you have to split the data into multiple components, that this is just tool selection and stuff. And then you have to kind of create different Google Sheets, but you still don't get the whole overview because you want to see the whole trace. It just gets very difficult. In the tools also, you can have annotations, so you can save annotations and then um, just save it to some test set. And so the whole process starts to get streamlined, that in one tool you kind of evaluate, create data sets and use those data sets again for evaluation. So that process can be streamlined better in a tool. If the tool comes with inbuilt evaluators, that's great. So you can have at least a baseline. Otherwise, you will have to create your own evaluators. Certain tools come with customizations as well, that you can select, as I was saying, the different components. You can essentially create your own evaluator, and then it can be processed in the tool itself, so you don't have to do this offline. So all of these challenges start to come in, and the tools also take care of a lot of rate limits that you might hit initially, and retries need to be done. And so there are like a lot of small nitty-gritties that the tools will help you. In the tools, essentially you will have the abstraction at the session level, which is like essentially the whole session of the chat, and there can be traces and there can be spans, and then it is basically tools, and all the spans and tools essentially have all the inputs and outputs that you'll be looking at. And one of the challenges, like the after certain turns of agents or chats, the inputs get pretty big, and so just going through those inputs also becomes somewhat of a challenge. So the tools, or the hope is that tool would make it easier to read those as well.
Any recommendations you can give on like tools to prevent these regressions, right? Once you have things into production, right, that's something that you should always be tracking, right? The regressions of that system. And that's also dev friendly. Any tools you would, that come to mind?
Also, I would say there are few companies into the evaluation space. We are also into evaluation.
Right.
We have a PLG product that anybody can sign up and start using it. It has certain limitations on the number of traces you can do, but their limit is enough for anybody to run some experiments. If they
Right.
people want to kind of use the open source solution, there is one by Comet also. And it's not important, I would say, which tool you begin with, unless you, of course, want to fix a tool, but start somewhere so you'll get an idea of what are the benefits, because a lot of people feel it's not important,
Right.
and get into trouble because if evaluation becomes hard, you don't want to do it, and then the system becomes unstable.
Yeah.
Then the step 3, I would say, is optimize your instructions for the agents, I would say. In that, as I was discussing earlier, simple tweaks often lead to unexpected behaviors. And for that, we need a system that allows us to do an A/B testing, because it looks simple that, okay, I'm going to run 10 experiments, but at times I'm running so many different experiments because I'm just adding some line, removing some line, adding certain schemas or examples, few shots, and it becomes essentially 50 to 100 experiments for just one system that I want to build. And we want to compare all of this systematically in a scientific way, not in a vibe eval kind of way. And for that, we need like hundreds of samples. My go-to number is 1,000 samples. Anything below it is kind of risky, but 100 is a good start, but eventually people should move towards 1,000. Other thing is that it often happens that you have prompt, you improved it, and then you did not version it, and then you want to go back for certain reason, and you don't have the old prompt, and you lost the old prompt, unless you have put it into a versioning system, like let's say simple system like GitHub, right? And you know that, okay, this was my old prompt, I can always go back to that. Choose anything available for this. I personally feel like just getting it done by GitHub is good enough to begin with. Don't add the tool creep that you have tool for everything. There can be different ways of handling this. You can just dump the prompt into a database also with different versions. But version controlling is kind of important. Otherwise, you lose track of time. And this last point is again about running A/B test and getting the exact numbers and comparing different samples also. It's not like aggregate numbers. You want to see that, okay, there was this edge case, and then I added this instruction into the prompt, and did it actually fix that problem or not, right? So you need a sample level, basically A/B comparison in the tool. So that is super important. The fourth step, like the prompting and instructions is like general, right? For the agent, like a lot of components would be there, single agent, multi-agent. All of those will require some instructions. This is specific to, I would say, if you have a RAG system, and any chat system, agent system might also have a context system, which can be just the context of the chat. And if they're just interacting with an external database, then of course there's some kind of retrieval system. So that is usually happening because everyone wants to build domain specific data sets. So for that, we need to have this is like there's so many things to improve RAG, but these are like the main things. If we get this done, we are already on a good path. And this itself takes quite a time. So first is the chunks, and there are a lot of ways to chunk the thing, but just make sure that whatever you choose has like enough proper chunk size and overlap, because that has a downstream consequence. Because if you're too big a chunk, maybe it's not a good embedding, and if you don't have embedding, then there's no point of encoders and retrieval, like re-rankers. So you have to do the evaluation on the final output. You can't just easily do evaluation on just the chunk. There's a visual evaluation that, okay, the chunk is looking sensible, it's not getting cut off midway. If it has tabular data or other kind of data, in structured in certain way, you don't want to cut it off. So you can have certain kind of a chunking system that would take care of all of this. Then encoder evaluation is going to be pretty critical for the success, because there are many encoders available with different embeddings, different model sizes. A lot of people just prefer to use like OpenAI embedding, which I feel is like still sitting high on the MTB benchmark. But if you want to have some open source, or the OpenAI's models are somehow not working, then you need to run some evaluation and tweak the chunk size so you embed it accordingly, and also vary the K that you want after the retrieval from the encoder. The size of the embedding will also dictate how much storage space you are going to spend in the vector DB. The size of the embedding will also dictate the retrieval speed. Probably you can always do horizontal scaling, but this has consequences which are super important. And if you're not getting the right amount of retrieval done, if you want the retrieval to happen in like top 10 only, and from encoders you have to put K equal to 50, because in certain situations the actual chunk is sitting at, let's say, 45th position, and you want to bring it to, let's say, top 10, then you kind of probably want to try re-rankers, so that you decrease the context size, because now you're going to send only top K equal to 10 to do the RAG, which will have downstream consequence of basically better latency and cost. So this three, it will take some evaluations to be ran, but once you fix it up, it's going to be really peace of mind for you. So once you have built the system and have the initial test cases, you want to quickly put it into your CI/CD pipeline. So I have spent a lot of time using GitHub Actions, where you trigger certain tests on the pull request pushes, and then you just run some tests. I mean, traditionally there were a lot of like just simple assertion tests, but now we are into like the agentic world, so we need to run this kind of test now. And you need to have, like, let's say, to begin with, okay, just to begin with, because every time you can't run 1,000 samples probably. Just to begin with, in the early system, you can have just like 10-20 samples which test for the most basic edge cases that you feel should not break to begin with, like obvious issues kind of thing. And once you set up, then you can deploy your system and changes with confidence, because even one configuration change is going to affect the system. It's very, very interrelated system, and you can have a criteria that, okay, only when all the tests pass, or maybe 8 out of 10 cases pass, or this particular test pass, only then I want to deploy the system. Otherwise, we are not going to do it. And it's very visible to the developers, so they can just discuss out in the PR and decide on what to do next.
How often should you be doing this? I think this is a really important for production, right? Use cases. How often is there like best practice for this stuff?
100%.
Yeah, how often
Simple things, yeah.
should you be running it?
Indeed, indeed, yeah.
Yeah.
Then this comes at a scale, I would say. It does not come in the beginning. Only once you have deployed your system, tested enough, and you want to kind of scale it to a lot of users, and your costs are not working out with the LLMs, or basically private or open source LLMs, the cost is not working out. It's also the latency that it's working out, but the latency is so high that users are unhappy that the app is very slow. And it's very well known that nobody wants to chat with a very slow app. So that can have certain brand consequences, that okay, they have the AI system, but it's so slow, you don't want to chat with it, and it can have some other downstream consequences of poor rating of the app and other things. So what we have found, and of course it's kind of well known in the industry, that you have LLMs, but they're general and they're good at many things. But if you just want the LLM to be good at one thing, you can just train a small model. In the region, we have found is like 2 to 10 billion parameter size models. They can learn how to evaluate, and if they know what kind of edge cases are happening and how to evaluate them particularly, then they will definitely learn that pattern, and then you will be able to put this into production, and you'll get the latencies in the region that you want. So we have run this kind of experiments a lot, and what we have found is that it's possible to get sub 200 milliseconds also, given the right GPU, right? It's a function of like the GPU, the context size, a lot of parameters go into this. But you can beat private LLMs on certain eval application and get the latency and save humongous cost. Like at a million scale, the cost is so huge that it starts to make sense to hire a few engineers, train some model, and just get it running. And we know that even for task, when the when the usage goes so high, then people really enjoy training some task specific models rather than using the LLMs from the private companies. So the cost reduction is huge. We have been running this experiment, and we have kind of released two models, which is one is 8 billion and other is 3 billion. And they've got like tremendously good accuracies on agentic evaluation and for other kind of tasks.
Do you have a link to these ones? I think those ones are interesting. Do you have like a GitHub link or anything like that you want to share?
So this is actually available only to customers who will buy the
Okay.
enterprise product. They're not open source right now.
Okay, not open source. Okay, cool.
Yes.
Yeah, so there were some questions here I wanted to ask you as well on this one.
Sure.
Because I think like I think what you're mentioning here is like the real-time monitoring, right? And allowing that to be as efficient as possible and as cheap as possible, because it can get super expensive. So there were two interesting questions here. The first one is like, if let's say you cannot afford fine-tuning like an LLM, right? Like fine-tuning a large LLM, I think the small language model is a good option. But is there
Indeed.
like from the like LLMs, the proprietary LLMs that exist out there, which one of these are much better in your experience for like production use cases to do like LLM as a judge, right? Which one of the models? Is it like the cloud models? Is it like the O3 model? Which one is the can you like comment on that?
Yeah, I'm smiling because I have the
Mhm.
answer for that in a very detailed way later on in the
Okay.
deck. So we'll
Okay.
discuss that in detail.
All right. All right. Fair enough. Okay, let's go. Let's proceed then.
Cool.
Yeah.
Then this is the obvious one again. Everything is very obvious, but I feel like it takes time and effort to do all of this. Once we have the system in production, we need to be really focused on capturing all the diverse user requests that are happening and what kind of failures that we see in production. It's a needle in the haystack problem, because it's like 1 million requests are coming every day, and you have error rate of let's say 5%. Then how do you find that 5%, and your evaluator is not perfect, so it will not catch probably all the evaluator, and you want to have a better evaluator so you can catch maximum of the errors that are happening, and then get it annotated by a team, and then add it to your main test set so that you can evaluate a system for these issues before deploying next time. So this is a heavy annotation effort, I would say, and the filtering, it's basically you recall all the errors that are happening with the judge, get it annotated correctly, and then update the test set. What we have seen is the evaluation, because LLMs are great at short context, but they start having issues at long context. It's very important to collect samples that are diverse across different context lengths. So I would say also focus on that as well. And then the tool calls can be very, very varied. Um, as I was saying, it can be just single tool call, it can be multiple, it can be duplicates, and with a lot of variations in the parameters. Sometimes LMs make assumptions. Sometimes you don't have a tool for it and it makes up a tool call. And so those kind of varied call errors, they need to be captured and added. So you need to kind of tag everything, that this is a particular kind of request, this is a short request, this is a request, this is a multi duplicate tool call request, and then kind of balance it out. Because if there is a majority of something, and the whole metric, when you evaluate your system again, if there is only one or two kind of edge cases that you are measuring on, rest you have very minority in your test set, you don't know how properly your system works. So you need to have a good diversity in the test set which matches your production use case in some sense. Then the last step is, this is an easy one, I would say, that it's possible to improve the metric with human feedback. That as soon as you see these failures happening and the tool shows you, you kind of annotate it and give an explanation for what went wrong there, right? And then this example and explanation can be added to the evaluator, such that next time when it sees this kind of edge case, it knows that, okay, this is how I should be annotating it. And the evaluator will keep on improving with time. It will be somewhat of a challenge, like how many samples you will keep adding to the evaluator, right? Because there are so many edge cases. So you need to come up with a strategy for that. But this strategy is, we have seen it's proven to work well, and gives you a much better evaluator compared to a baseline evaluator, because it's difficult to imagine the kind of failures that are happening unless we see them. When we see them, they're obvious, but it's difficult to imagine. So when we see them, we annotate and we add it to the prompt of the judge to make it better.
So it seems there's a lot of like human insight and work that's going on, right? That doesn't go away, because I think there is a I don't know, there's a push for more automation, especially on evaluation, just because of how costly evaluation is.
Right.
But what you're suggesting here is like human feedback, human insight, and expertise matters so much to get these systems, over the edge, right? To get them over that threshold where they're like, okay, this could be used in a production setting, right?
Correct. So initially, there'll be hand holding from the human team
Right.
for improving the evaluation system. But
Yeah.
over the time, we should see ideally that the evaluator is catching most of the issues if the system is stable, right? But a lot of in production system also have divergence from the beginning, right? There's a lot of drift, different
Yeah.
kind of use cases can come up that were not there. And it's a function of like what is the product, and there is a support thing. If there is a bank, let's say there is a 50-year-old bank and does the same thing, there are no new credit cards coming out, same offers all the time. Maybe over the time the evaluator learns all of these issues and becomes stable, right? So if the
Mhm.
product is not changing, then user requests are not changing, and so errors are also the same. And then once you add those errors into the prompt of the evaluator knows, okay, I need to do this in this situation. So that would be a really good use case. But apart from traditional banking and other things, a lot of products just change.
Right.
Even in e-commerce, thousands of products are coming every day into the e-commerce website. And so new
Yeah.
products are launched. And so for certain situations, I think it's difficult to have. And so some human hand holding has to be done.
Right.
So overall, I would summarize this in this way, that to build an evaluation system, we need to collect all the signals that are coming from different places, the prompts, the tools, the errors, the inputs and outputs that we are giving. We need to analyze it, and then we need to have a system that gives us the insights and makes it easy to do the job. So it's like, as I was saying, low level errors, high level errors, and there is also like should be an inside engine which looks at all of these errors and tells me there were this 20 errors of this type, there is like 5 errors of this type, and so first focus on this 20 errors, fix it, and then maybe fix the five errors that are having 5 times, and then in that fashion I can prioritize my fixing of the agent. So once we have this system, it becomes much easier to have a more stable agent system in the production. The part to POC to scale basically narrows down. There'll always be some time, few months, but you don't want to be 1 year, right? Because no project survives 1 year. It's just going to be failed. And we can just narrow it down to like, let's say 3-4 months, and make it successful. So now I think you'll get a feel of what I was telling in the beginning, to have the integrated observability and the LLM metrics that makes this possible, to have a system that we build a system, we evaluate it, it works, so we deploy it, but we see some more errors, we annotate it, uh, and then we again add it to the test set, we improve the system, it passes on all the old and new tests, we again deploy, but we see more issues. And so, but the issues hopefully get lesser over the time, and the system becomes more and more robust in nature, so it becomes more reliable. So that concludes all I wanted to talk about on the playbook for making reliable agents. Now I'm going to share a brief on what we have been doing on the agent leaderboard. As some of you might know, we launched agent leaderboard V1 in February, which was an effort to evaluate different LLMs on tool calling. So just have different scenarios of tool call, as I mentioned here and talked earlier: single, multiple, long context, missing functions, a lot of different domain use cases were there in it. And we have taken public data set, the famous one like Taubench and BFCL and others, to make this possible. But we felt that this is not enough. We need more realistic evaluation, much harder evaluation that is actually happening with a lot of tools. Like industrial applications will have more tools, like 10 to 20 tools, because that's at least the minimum skill set an agent should have to be a real support agent. So we incorporated a lot of the weak points of the V1 and built the V2, which consists of completely new synthetic data sets. What happens in that is, we have come up with prompts to create different kind of tools. So we have 5 domains, and for every domain we create 20 tools which are complex and realistic in nature. And the tool definitions look exactly like how we pass it to OpenAI models or other models. Then we generate a lot of personas, because we know that different people can have different personality of interaction, like people from different occupation, from different age, from their gender, some background history on what they are. And we create a lot of challenging scenarios, which will consist of 5 to 8 interconnected requests, which capture like real world complexity. For example, it would be like, I lost my credit card, I want to block it, issue a new credit card, and I also want to pay this bill. So it's like 4 requests straight away, and the agent needs to accomplish that. And so we do this for different domains. Different domains are like basically banking, investment, healthcare, telecom, and insurance. So we simulate this using these data sets and scenarios. We simulate that, which I'll show in the next slide. And this becomes essentially, this 3 thing becomes our complete benchmark, which consists of tools, personas, and scenarios. And essentially we created something which enterprises are also evaluating internally, and it's realistic in nature, not just if you look at the benchmarks from research papers, they would not sometimes feel realistic in nature because they have been created for certain other reasons. So in the simulation, the setup is very simple. We take the data set I showed you earlier, the tools, the personas, and scenarios, and we plug it to the models. In the models are used for three things. The agent itself, right? So we are evaluating different LLMs for this agent of this different domains. So we plug the LLM to be evaluated to this agent. An agent is told that you are a banking agent, you're supposed to do this, and you have these tools at your disposal, and you should be just completing up the user request. You should not be talking about anything else. Those kind of instructions are given to this agent. And you have a user simulator, because we can't actually run real scenarios. You have a user simulator which has persona and a goal, and the goals to be accomplished. So it will drive the conversation, basically chatting with the agent that, okay, I want this, I want that. And because we don't have real tool, because we don't have the databases and stuff, we simulate the tools again with LLMs, and we run this iteration with one message, and then agent response and tool calls, and then again response to user, and then again user asks for something and agent response. So we run this simulation, and complete the simulation, and then evaluate the whole interaction with the low level and high level metric I was talking about. So it tells, the metrics tell me like where the tool selection failed and where the whole task was complete or not, which we, in our case, in basically these are terminologies from Galileo. We have named our metric in with these names. So action completion and tool selection quality. And from that, we know where the tool call failed and which of the sessions where uh, the agent did not complete all of the goals, and that we give it 0 if it fails. If it completes all the goals, then it's a 1. So this is how the simulation looks like. And over here, as you see, it starts at the top, and then there is turn 1, and then agent responds, then there is turn 2. Usually what happens is, like in first turn, the agent asks for some information that, okay, if you want me to complete this, give me your bank account, give me the credit card number or something like that. So that is usually the first, and then once it gets the information, it starts to call the tool, complete some of the task, and then again reports that, okay, I complete these things. For the next things, I want this information, and then it completes the other stuff, and then kind of ends the whole thing. And in the product, we can kind of get the metrics, and we get the explanations. Okay, why this is 100%, or why this is a 0, why has it failed? In my experiments, I wanted the highest kind of reliability from the judges. So from our V1, we knew that Claude 3.7 is really good model. And we have done a lot of annotations to see whether it's actually performs. And so I use Claude 3.7 as the evaluator for my metrics. And this is how we kind of get the numbers for all the simulations, for all the domains, and for all the data sets. So this is the leaderboard right now, and the ranking shows that GPT 4.1 has won, but it's still not perfect. It just completes all the actions, all the goals of the user only 60% of the time, kind of 60% of the time. So the current models are not perfect. Of course, you can improve this with certain prompting and stuff, but we have seen certain kind of obvious issues. So there will still be some issues unless you are like a guardrail, and whenever it makes issues, you stop the agent and bring in human in the loop. Those kind of systems needs to be built. But we found that in certain scenarios, it breaks in a very obvious, silly ways. So one way to rank the models is by action completion. Another way to rank the model is by tool selection quality. Models are better at tool selection, but they often either forget to complete the task or make errors in completing the task. That's why they get poor action completion. We can also see the actual cost of a session, and it's pretty low. So this is great. Intelligence is pretty cheap these days. So for one user interaction session to complete like 4 or 5 goals, it takes like very low cost. So from cost perspective, it looks like models are really great. Duration wise also, they're not taking a lot of time. For on an average 3 turns, they are just taking 24 seconds. So 8 seconds per turn is, I think, still very humanly, I would say. It's not a lot of time. So from this, what we saw is OpenAI is a top, Sonnet somewhere below, Then open source comes in with Qwen 2.5. Qwen is one of my favorite models. Gemini comes back, then DeepSeek. So we have like taken combinations of both open and private models so that we get an idea where the open source stands right now. And yes, they are pretty close. There's a 10-point gap, but it's not bad, I would say. So open source is definitely closing the gap. So this is our effort. And coming to the question that was asked previously, like what's a good model for evaluation, right? What I have seen in practice, I would suggest two models. Go with Claude 3.7 or 4, Sonnet. Opus is great, but super costly. So I don't think anybody would be able to use it at a scale. If you want to run some simple small experiments, yes, go for Opus. You will provide the best evaluation possible. And on the other side, GPT 4.1 is looking also very solid from our experiments. So these two models I would recommend to anybody.
So I shared the link, Pratik, in the chats for anyone who wants to check it out. I think it's just wanted to add a comment here. This is super interesting because not all tasks, right, from every domain is the same. I have a feeling like GPT 4.1, in my experience, has been really good at like instruction following, and it can do
Yep.
better at long horizon tasks, right? So
Yes.
I think
Yes.
this is revealing that it's not just about like selecting tools. It's also about being able to complete the task, right? And being able to
Correct.
understand the instructions and be able to do the multi-turn stuff too, which is also very challenging for the systems, as
Correct.
I think reports, some research has reported recently about this too. But it's really, really interesting. And I shared the link just if anyone wants to dive deeper. I highly encourage everyone to go and check it out. I always find that these leaderboard stuff that you guys are pushing out are just revealing a lot of insights, right? And there are things that we can kind of share and kind of inspect a little bit more deeper. So I like all the data that's providing too. So I highly recommend it,
Thank
everyone.
you. Thanks a lot. Yeah, indeed. I think the multi-turn and long context are still challenging things for LLMs, where they can just forget what they were asked previously and they can make like formatting errors. Um, so it's important to basically evaluate for short context as well as long context. As I was telling in the evaluation data sets, you need to have that diversity based on like how the real interactions are also happening in the app. Other insights we can get from the agent leaderboard are essentially the infamous cost versus performance chart, where this axis is the performance, which we are by default we are doing it action completion, and this is the cost. And over here we see that GPT 4.1 mini is really low on the cost and slightly behind 4.1. So if anybody is like constrained on the cost side, they can go with 4.1 mini. But as we saw, like the cost per session is not so high. So I would still recommend going with 4.1 for the people. And over here, we have the region for the models, which should be avoided because they're low on action completion. And then it doesn't matter whether it's cheap or costly, right? So things on this side should be avoided. Then we have the latency versus performance. Over here, again, we have the performance and we want the latency to be low. So where is it? Slow. So over here, we have slow and inaccurate, and then we have fast and accurate over here. So high action completion and lowest time. So over here, we have the GPT 4.1, which is a big model, but still very fast, which is super impressive. 4.1 mini is also nearby only. I think the 4.1 mini is quick, but what might have happened is that the number of turns for GPT 4.1 mini might be higher. Yeah, it's 3.4. So over here it's 3.1. So in certain cases, it's taking more turns to get the job done. That's why the uh, duration is coming out to be high. So it's important to know it's a duration of the session. It's not latency that we usually talk about. So in that fashion, 4.1, both 4.1 and mini are both amazing. Sonnet 4 is also there, but as you see, duration spikes up. Then we have Qwen 2.5, which is also quite impressive on the open source side. And the performance of open source will depend on like what kind of quantization you have, what provider you are using, or if you're hosting it yourself with GPU or you're hosting. A lot of people like L4 GPUs, but if you want high performance, you might want A100 and H100 and other available GPU servers. So this can change, but this gives you an idea of what it looks like. And just to give you an idea of like what I meant by action completion scoring. So we have this, let's say, a simple banking conversation where it says, I need to dispute a fraudulent charge, then transfer 4,000 and set up text alerts over $20, over it's 20, yeah, and schedule 750 monthly rent for Jake. Also, there is order a new debit card and ship it express and pull a 45-day statement. So there are like many things asked. Okay, this is just genuinely done to make it difficult for the LLMs. And what we see is that the task completion, like whatever the metric will build on a higher level, will say that uh, did this task correctly, but it failed to complete this. And so this was not a successful session. So this is how what I was trying to say when we want to have a high level metric. Then we try to, there's a lot of controversy around leaderboards. There was a scathing paper written recently, the leaderboard illusion. There was also response from LMSs on how they think about it and how they're going to improve it. And there was like controversy around Meta, and a lot of things happened recently. And so we have been observing those and trying to incorporate the best practices possible in the given time that we have. And so what we tried to do, one of the most important thing we wanted this time is that we want our own data set rather than any open data set, because it's very easy to get this leaked into the training and then you don't know whether it's completely fair evaluation or not. And there have been other papers proving that certain models are more prone to leakage of data than others. So we wanted our own data set. So we built it completely synthetic. Of course, it's synthetic, so it's still something coming out of some other model, but there's like multiple things going on in the simulation, so we hope that it does not affect too much. Like if you see this, we use Claude 3.7 for a lot of synthetic generation, but it's not at the top. What is at the top is GPT 4.1, and for evaluation also we use Claude, but still 4.1 is at the top. So there is not a psychophancy issue as much as we think about. So hopefully it's all good ranking. Then it's all LLM based, Plot 3.7 best possible that we used. Then we have the balanced domain weighting. It's not like we are giving a lot of importance to just one or two domains. There have been papers in the past where there were just two domains. In the top benchmark, there's just retail and airline, but we try to put more domains so that we can get a better aggregate. And we have efficiency tracking as well, showing the cost and the duration. And we are open sourcing the scripts as well as the data sets in the next week. So people can just take this and run their own and then kind of get a real idea, and they can replicate the experiments as much as possible. Only thing is that they will require to use our metric to get the numbers, and because metric is hard to build, so we have not open sourced it, and they need to use the metric to kind of get the number. But if you see at other leaderboards, they kind of have data set that is not open and a lot of information is not open, so that kind of creates a transparency issue, but we have tried to keep this as transparent as possible. So whatever you build in the agents, whatever LLMs and architecture you use, this is an extra slide, I would say, that you'll have to make some trade-off between the three things: cost, latency, and reliability. So if you want cost and latency to be solved, then you want essentially small and low performance but cheap models. If you want latency and reliability but cost is issue, then you want um, small high performance. I call latency, and okay, latency has to be solved, so it will be usually be small and high performance but costly models. And then if you want cost and reliability to be solved, um, you want large and high performance. Why this is important? Because if you're user facing, then you would be worrying about the latency, but you also be worrying about the reliability. Cost you might sacrifice if you are user facing. But if you are building certain workflows, and it's okay to have some errors probably, then latency might be not the important thing, but cost and reliability might be the important thing. So this is how you can use this triangle to kind of make trade-offs. So this is all, guys. I hope I was able to convey the ideas that I have been accumulating, and hope this gives you some clarity around how to improve the agents. It's a very complicated topic, and I don't think I've covered even like 10-20% of it. It will be like a long session. But yeah, I try to capture the patterns so that you can utilize it and make things better.
Well, thank you, Pratik. This was very insightful. I mean, like all the the playbook, all the different like recommendations. I think are things that I'm seeing and really important to to be aware of. Like the metric selection stuff, I think is really cool. Um, all the stuff that you mentioned on production, right? The CI stuff, how important that is for production use cases. I think one part of the presentation I really liked was the trade-off stuff, right? Because I think you have to think about trade-off all the time. Like, you can't get like the perfect world where you get everything, like latency, cost, reliability, you get everything. But it's usually is the case that you kind of need to have some kind of trade-off, right? That was really interesting to see. Really interesting part
Correct.
of the presentation. Yeah, cool.
Well captured.
Yeah. I have a few questions if you don't mind. I mean, we are way over time, but there were some
Oh yeah, that's
questions.
good.
Yeah. So just some questions from the chat. Maybe I'll just pick two questions here, top two questions I think that are more relevant. So
Mm-hmm.
there was a question here about you were talking about the embedding stuff, right? The retrieval stuff.
Yep.
Is there like a benchmark or some public resource where you can check, which one of the models, which one of the embedding models are the right ones to use? I think you guys have built great resource for the agent leaderboard, but I think there's not a lot of resources that I know where you can go and check to see which is the embedding model that we should be using maybe for a specific domain. Anything that you can recommend just in your experience?
Correct. Yeah, good question. We were also very curious on this topic, and
Yeah.
we created hallucination index last year.
Hmm.
It was
Yeah.
RAG focused, right? For
Yeah.
answering the same question, because it was not very evident from the evaluation that was happening on different benchmarks. But I
Right.
would say that this I don't remember right now because I've not checked recently. But you can, and we are creating data sets using the available data set. So it was a mangling of the data set to get the data set for evaluation. What you can essentially do, I would suggest, is go to MPEB leaderboard and select the models for the embedding size you're okay with, and either private or open source options, whatever you're suitable. Take the top 5 options available and then evaluate for yourself. As of now, I was just checking the leaderboard, and it looks like there's Qwen3 embedding 0.6 billion model, and there's like also, I think, 4 billion model, which are doing superbly well.
Yeah.
And if you want direct embeddings, I think Cohere embeddings have been quite famous, and there's also OpenAI embeddings. So just take up these 4-5 models. Don't take very large embedding size, otherwise you're up for a trouble. Because just for the leaderboard, more people have created really large models with really large embedding size, which I think is not good for practical purposes. So just filter out top 5 models from it, and then just evaluate for your use case with some. You can do vibe testing with just some handwritten hard examples that you feel,
Yeah.
and if it works, then create a small data set and evaluate it. I have actually a blog on how to evaluate embeddings on my own blog also, as well as on the Galileo's website. So you'll be able to find that.
Yeah. So I have one more question for you here before we let you go. So this is more about production use cases. From what you have seen, right? From what you have seen from customers, I know you guys work a lot with the enterprise. Are there like any like surprising things that you saw, the people that are building like agentic systems in production, right? Any surprising things there and how evaluation might have helped to sort of mitigate those surprises, which usually are like big issues for companies. Anything that you can share, maybe one or two?
Mm, I think there is no surprises, I would say. Everyone is facing the same basic issues,
Mm,
and they just want to get a single agent system, right? And a lot of companies have already started building multi-agent systems, and things are moving very fast. I am hearing a lot that even traditional companies are building multi-agent systems, and they want to have a system for evaluation, and there is no clear-cut path right now on, okay, I build this orchestrator agent system, the manager, and then multiple agents under it. And then people do not have complete clarity on how can I tweak all of these agents separately. What are the metrics I should be using? Those kind of simple confusions arise usually. And our recommendation is just go with these basics first, and just spend time. It's all about the basics and just looking at the data. What happens usually is that people build the systems and then just don't check into what's coming into the system. What's happening is, there were, as you remember, there were data scientists and machine learning engineers which were trained to annotate, get the data. It was data first world, right? After
Yeah.
that, only you think about systems and models and stuff. But nowadays, a lot of software engineers and AI engineers have come into the play, and they are not trained well for looking at the data. It's not their domain, right? And so all the engineers need to have that habit of constantly checking where the error happened, what was the input, why is it happening, and that rigorous discipline is absent in many places, because of which all these troubles are happening. So
Yeah.
it's getting very complex for sure. Earlier it was just simple system. Okay, I have this Q&A, I have this classification with LLM, right? Then it became slightly rack. But now it's like
Yeah.
so much assembled system. It's not
Yeah.
easy for one person. You need a team that has multiple experts on different topics, so that if anything blows up, you know whom to delegate the work, and then that person can actually look into the thing and fix it.
Yeah. There's no way to, no better way to end this than what you just said, which is looking at the data, right? Get the basics first, and then, go from there. But looking at the data is so important for this stuff. I couldn't agree more
Indeed.
with you. Well, Pratik, I shared a few of the resources, the leaderboards, the version 2 as well. I've been taking a closer look at that as well, and encourage everyone to look at that. I shared your blog as well. Anything that you would like to share before we wrap up here? Any like new stuff that you guys are working on, that you would like to share with the group?
So Agent Leaderboard V2, I've been talking about that in public for the first time over here. We are going to launch it
Awesome.
next week. So
Yeah.
it's an early release for fans and friends. So don't share it right now.
Okay.
Yeah, you can share the slides. Don't share it right now. I would
Awesome.
request that when we launch it next week, help us promote it
Yep.
during that. And we are going to do agent related launches in the coming days. We are working on a lot of insights, so that what time people are spending on evaluating agents, that gets reduced to a few minutes rather than hours. Because if you look at some places, people will report that it takes 1 hour or half hour to just debug a trace, which is
Yeah.
insane, right? We don't want that to happen, because you can't improve the system in that manner, because you have to annotate hundreds of samples in real scenario. So
Yeah.
we are working heavily on reducing that time to insight. So those
Right.
launches are going to happen, and that required a lot of research, experimentation to come up with that methodology, which is not super costly as well as very effective in getting us the insights.
Yeah. Cool. Well, thank you so much, Pratik, for all the insights. I really appreciate this. I think everyone, took a lot from this, a lot of insights. Hopefully we can get your slides and we'll share it also. But please, everyone, don't share this publicly yet, like you said, like the Agent V2. But excited for the launch, and we'll be also sharing it with our community. So thank you so much, Pratik, for your time. I'll see you
My
soon.
pleasure.
Thank you.
Yeah, thank you so much, guys.
Thank you, everyone. Bye-bye.
Bye.